Hey guys, how's it going? Let's see, load up 08. Sweet, that sound is good. Wow, 188 people. Man, surely you guys got something better to do than attend this stream right now. Is there still an echo, or is it all good? Whew. Okay. All right, guys. Thank you for all the lovely comments there. But look, we've got to get. I mean, what we've got about 12, maybe just over the 12 hours left for this exam. I know I can't even keep up with the comments, to be honest, because it's just like that's currently on a bit of a very tiny slow mode as well, and it still going through. Stacy, I think I've already done all the exam question papers, so I'm not gonna spend any time going through the exam questions, especially the ones that I've already done for NCEA. So I've got a few questions that I owe people from last night. So let me just have a quick look through it, because literally it came, what is it? I've got like about 30 questions. It's actually there at the moment. I don't think I can go through all of them, but I'll see if I can pick some of the questions that I haven't done before, so that we can kind of at least get somewhere. Look, to be honest, it's always hard to try to do a live tutorial just before the exam. So just to kind of break it up a bit, so we can actually damn it. Okay, that's on. Let me just put that on mute. Give me a second. Let's just close Instagram there, because otherwise it's going to keep buzzing off. So what I would recommend, guys, is this. If you are here for like excellence questions or anything like that, I would still recommend you guys just to just kind of watch those old exam videos. As for now, in this session, what I'm really going to be working on is those exams that people actually sent me. Now, I know that doesn't mean flood my email and Instagram with questions, because I was supposed to finish off a few questions yesterday. So I'm gonna try and finish those questions off, because at 9 o'clock I'm gonna wrap this up real quickly at 8:30, because at 9 o'clock I've got a calculus tutorial with the for excellence questions, doing level 3 calculus, not level 2, sorry, level 3 calculus. Look, just kind of look over what you can get. Look, it's so hard to say, right? Like I think for you guys, like a couple of tips that I'll give you guys is this, and then after that I'll answer a couple of questions. For starters, like if you've been kind of like revising for the last week and a bit, it's gonna feel a lot overwhelming, but it's okay. Like it's just you go in and you attempt the questions that you actually know. As for guys that are trying to aim for achieved, there are always watch the live tutorials from the start of the year. So every year that I release live tutorials, I do a lot of basic stuff, right? So powers are powers, logs, and discriminants. So if you're aiming for achieved in this paper, those 3 kind of little skills will always help you go a long way. So that's like your power of powers, or you know, like I'm talking about things like this. So sometimes they give you some really nice questions. Questions like, you know, they'll say write with a positive power, for example, and your question might look like this: 2x cubed over 2x to the power of 8. I don't know, that maybe that might be minus, and this might be 8. I don't know, something like that. And then they'll say write in positive powers and stuff like that. So learning to manipulate those basic algebraic rules will really help you guys out. Also, things like this will also help you out. So if you have something like, sometimes they put questions like this: if x to the power of 3 over 4 is equal to 10, find what x is. Then you can just put down x equals to 10 to the power of 4 over 3. So kind of understanding when we can actually do the flipping of the powers. All right, and then log rules. If I remember correctly, you guys will get a level 2 formula sheet. So where is it? That's the question. Let's have a look. So with the level 2 formula sheet, you guys are going to get, I hope this is it. Yep, that's the one. So this is the formula sheet that you guys will get during the exam, right? Now, so if you look at, I mean, like all of your, these little formulas, they're super, super useful. Log rules. Now, those guys that actually come out and say, oh, logs is really, really hard. I'm like, man, logs should be the most easiest thing for you guys because they actually give you guys all the equations, right? So it's just kind of like matching them up and kind of putting them in the calculator. Now, this particular thing here, log by, all right. Sometimes people ask me, is like, you know, how do you put that in the calculator, all right? So I'm gonna show you guys that real quickly because I know the people that want to achieve like really want some really quick shortcuts. So if you have a question that looks like this, which is y is equal to 3 to the power of, no, not y. Let's go something like 20 equals 3 to the power of x. Hang on, let me just switch over the screen so you guys can see it. So let's say you got something like 20 equals 3 to the power of x. Then, you know, if I go back to that log rules, then you can write this as x is equal to log by, which means x is equal to log 3 of like 20. And I'm going to go back to my writing here. But some people ask me, how do we put this in the calculator? All right. So if you want to put this in the calculator, guys, like all you have to do is just rewrite this as x equals to log 20 divided by log 3. So if you go into the calculator, just go into your normal main menu and just your normal menu. So you can go log 20 divided by log 3 is equal to 2.72. Now, a good way to check this, whether you're correct or incorrect, is of course, if I do 3 to the power of 2 is 9, 3 to the power of 3 is 27. So I know I'm correct because 20 is actually between 2 to 3. Yeah, so you can kind of go, yep, that's fine. I'm going to leave that as an answer there. So that's something that's worth remembering. The other thing is that's powers of powers, right? Like just some really basic stuff I'm just covering there and logs. Logs are going to be super useful. You know, even if you're like, oh, I'm freaking out about tomorrow's exam, I would say just go through, do a few logs, few basic powers, and then discriminants. You are not discriminants, like learning how to use the quadratic formula or even the discriminant is like really useful. So again, if you've forgotten, like I know there was a question on I can't remember where, like sometimes I just get messages from everywhere, like Instagram, YouTube, email. Somebody asked me, it's like, when do I use the quadratic formula and when do I use the discriminant formula? So if you remember, the quadratic formula is just b squared minus b. Discriminant, sometimes it's put as a little triangle, is just b squared minus 4ac. Now, with the quadratic formula, you're actually looking for solutions, like exact solutions of x. With the discriminant, what you're trying to figure out is like whether the graph cuts it twice, whether it cuts it once, or whether it doesn't cut at all. So that's kind of something that just to keep in mind, right? So this, I mean, even if you remember this little greater than 0, b squared minus 4ac is equal to 0, and then b squared minus 4ac is less than 0. So for achieved, if you can kind of go through those three things and just kind of like practice that over and over again, you should be all good for that. I think I did one question yesterday, dive deep. Sorry, I'm just kind of like I can't keep up. I really can't keep up with the comments there, guys, because it's just like by the time I read one, it's like so many of them go through. Yeah, so that's kind of like, you know, for achieved for algebra. For calculus, the one thing I'll say to you guys is that, you know, if you get stuck with differentiation, I mean, like, differentiation is something that's a must. I'm scanning the comments, I can see kinematics. In my live stream tutorials, like, I'm looking at particularly this one here. So if you guys go, and if you're like, actually I need some help right now with kinematics, just head over down to level 2 calculus tutorials, and if you click on view full playlist, right there on August 19th 2020, I did a very good, I think it's a very solid kinematics type of questions in there. So all right, now I know this optimization keeps coming back, right? So with optimization, like, people keep asking, like, how do I do optimization? How do I do optimization? All right, let's go do a quick optimization question. And I think, I can't remember if I did one yesterday or not, but let me just have a quick look. I thought I did one yesterday. So what did we do yesterday? Did we do an optimization question, or did we just do quadratic? Yeah, we did do an optimization question yesterday, guys. But like, look, optimization question, like, I mean, like, I don't know, I'm just going to make up a question on the spot. I mean, and I always struggle with optimization questions, but like, just coming up with the context of the question, right? So with optimization questions is that, like, this is kind of like your standard bread and butter for optimization, right? So let's say you got something like a triangle, a rectangle, I don't know, so like a trapezium here. All right, and then they basically say that short side is, I don't know, long side is twice of short side. I don't know, something along this line. So then we can say this is going to be 2b, and then this is b. They might say, okay, this distance is going to be like 8, for example, and then you might get like, I'm trying to think, like h. No, that's not going to be possible. No, that's not going to be possible. I shouldn't see. This is why I shouldn't make up questions on the night, because I always end up doing something stupid. Maybe not a trapezium. Let's actually go with like, a cuboid here. So we can say height is twice the size of base, and base is a square, for example. Let's say the question looks like this, and you know, they might actually say something like all the sides, like I'm talking about all these little edges. So they might say something like all the edges add up to I don't know, if you're putting like tape, for example, you might say, all right, that's 100 centimeters of tape. What's the biggest volume you can do? So no, I'm not doing that question again, DPC. I think people can catch up with it yesterday. So basically what we've got here is like, you know, how do you do this optimization question, right? Like, basically we know that all of these edges here, so that's basic, like, not basic, I've said like basically so many times, but like, all the edges add up to 100 centimeters. So how many edges are there? Now, the first thing we want to do is we've got 4 heights. All right, so there's another height at the back there. So we've got 4h plus, we've actually said that the base is going to be a square. So we could actually have b. But what ends up happening is we've actually got 8 b's there. So 4h plus 8b is equal to 100 centimeters. All right. So with that in mind, what you can do is you can write an equation for the maximum volume, because we want to know what the max volume is. So volume of this cuboid is equal to base times height. All right. And then what we've got is, oh geez, man, like, seriously? Need to chill out, guys. So what we've got to do is we've actually got to write the volumes equation with one variable. Right now, if you look at it, we've actually got b's and h, but we need to rewrite that, which, well, it's not like simultaneous, well, kinda in a weird way, because if you look at it like this, who was it that asked? I don't know, I lost the name. It was somebody was asking me, Eric. So if you look at it like this, you want to replace the letters, right? So it's really important that you just want to replace the letters. Now, if you look at this, I wouldn't call it simultaneous, but I'm just eliminating one of the variable. So I can rewrite this as, well, I shouldn't have actually put the twice of base there. Let's just leave it like that. Base is a square. So then I can rewrite this as like 4h equals 100 minus 8b, and then h is equal to 100 minus 8b divided by 4. So height is equal to 25 minus 2b. So then what we can do is we can actually replace the height in the volume equation. So we can actually rewrite this as volume is equal to base b squared multiplied by 25 minus 2b. So expanding this, we're going to get 25b squared minus 2b cubed. So now that we've got this equation for the volume, is the total surface area or the area of all sides? So next step is like we actually differentiate this. So we're going to get 50b minus 6b squared. Put this equal to actually 0, because that's when we know maximum happens. So we're going to put 0 equals 50b minus 6b squared. Take out b as a common factor, so we're going to get 50 minus 6b. And so what we then have is b is equal to 0, or 50 minus 6b is equal to 0. So rearranging this, we're going to get 6b equals 50, and then b is equal to 50 divided by 6. So 50 divided by 6, we put that in the calculator. I think, what do we got? 80.33, is it? 8.33. So literally, guys, when it comes to optimization, is write down what are all the information you have. Write down the formula for whatever you're trying to find, and then what you need to do is get rid of the one of the letters. I think you drew the tangents to the curve for question 3C and 29 paper incorrectly. Really? Wow, did not see that one coming. So, oh man, I can't actually pronounce your name, but you're asking me about surface area. So if you're doing surface area, what happens is with surface area, you'd write the equation like this. You've actually got like the 6 sides that you need to add up, right? So I'm looking at the bottom side, b squared, multiplied by 2, because that's, you've got the top as well, top and bottom, plus 4 lots of b times h, which is your 4 sides. So in this case, your surface area will become 2b squared plus 4bh. And once again, what you got to do is you've got to actually put replace h with 25 minus 2b, and then what you do is you would expand, differentiate, put it equal to 0, and then yeah, solve it, and then you should be getting it through. Sorry guys, just got to clean up chat for a while. What to make volume equal to when trying to find minimum volume? Matthew, I think most of the time their questions that they ask is maximum volume, because minimum volume, we can assume that if you adjust the variables, your minimum volume is always going to be 0. Because if you think about it, if you have a base of 50 and 50, that's your edges done, right? Like, because you've only got 100 centimeters for the edges to add up. And actually not even 50 by 50. If you put 25 as the base, because then you'll get 25, 25, 25, 25. It's just a square, flat piece of square on the ground, which has 0 volume. So we can kind of assume that volume for minimum will always be 0. Is this an excellence question? I would say, yeah, it's pretty much. Hang on, man. You keep bugging me about this question 3C in 2019. Let me go have a look, all right? 2019 paper should be here. PT, you keep talking about it. It's like I keep seeing it again and again. Was it 3C? Please, 2019 question 3C. Okay, let's find out. What's happening with this 3C? Did I stuff it up somewhere? All right. I'm putting this 3C up there. Both have negative. Why is only one drawn with a positive gradient? Okay. So I'm guessing PT and Ani, you're actually you're talking about this thing right here. Am I correct? Yeah, so why have I done that? Why have I done that? Well, okay. I know why you guys probably got confused with that one. Okay, look, it's I like it's written in variables, so it's, you know, if the y value is actually negative, then if you think about it, then that's a curve that's actually going, it's a negative curve, but it's relative. Like, oh, it's so hard to explain. It's like okay, like this, for example. Let me show you another slightly different example to see if it makes sense. If I tell you gradient is equal to y2 minus y1 over x2 minus x1, all right, so if I actually put that, and if I actually say that this is it looks like a positive gradient, but what if I put the value 0, 0, 5, negative 4? All right, if I put that, what happens is when you substitute the gradient, you're going to get negative 4 minus 0 divided by 5 minus 0, which means you're going to get negative 4 over 5, which actually gives you negative 0.8. So all I've done with that question is that I've just put it relative to that. It doesn't mean that it's actually a positive gradient. It could look like a positive gradient, but in reality, it's actually it's just because of those letters, we don't know where it's going to look like, whether it's going to be positive or negative. So I've just put it kind of like a generic one. And I hope the example that I've did in the black kind of makes sense, because theoretically we know that 5, negative 4, the graph actually, like if you generally have like 0, 0, 5, negative 4 is actually here. So you know that that's a line that's actually going down in the negative, but when I just drew it quickly as a reference point. But that person with the extremely long name, I think you can put or and. I don't think I usually put comma, but I can't remember now. Like I know in some papers I put and in some papers I put or. Now, light and darkness, it's not simultaneous. It's basically like, it depends, right? Like once you put the equation all in one variable, then you should be... No, but Amy, sorry, is that Amy? Amy, but what if the cubic actually does this? It just tells you the tangent to the graph passes through the origin, right? So if you have a cubic, you could have a cubic that looks like this, and then where this tangent is actually going like that. So it is possible like that. I just drew it slightly different, that's all. Yes, level 1, I think we're going to be doing like one more tomorrow night, just looking at exponential equations, and then we'll call it. I see what you're trying to say. Give me a second, I just want to have a look at the old answer schedule. Just in case I missed something. 262. Schedule. We might have to actually put this on Desmos when x equals to a. The gradient of the tangent is that. Let's have a look. Give me a second, guys. Just need to load this up on. Yeah, Erin. I wish I could do that too, because geez, there's just so much to cover, guys. I don't even know where to kind of begin with. But let's actually go have a crack at this. So, in this question, we actually have. We have x cubed minus 3x squared. So here is the main problem. I've been drawing the graph wrong, right? I just sketched the graph. So you could actually have a tangent, like if you look at the two tangents that we actually get, which is negative 6.2x. There's one there, which actually goes through the origin. And then the other one was negative 4x, which also goes through the origin. And if I zoom right in, I'm actually going to end up with the two, like you can kind of see the tangents happening there. So the first tangent is here. So that's that 1.5, negative 9.375. And then there's another tangent which is actually happening at 0, 0 itself. Amy, it's a tangent because it's actually touching the graph at a slight point, and so that's what it's doing. So if you look at the 2 points, like at 0, 0, it's actually a tangent. And then if you look at the blue one is actually touching the cubic when this is happening. But then it's tangent, and then it still manages to go through the origin. And if you look at the other one is actually a tangent at the origin itself. So that's why it's actually going through the origin. Okay. Well, sketch the graph of a straight line. Hey, look. A few people have kind of been like asking about this, like, and again, this is like a really quick little way to get. Again, for calculus, it's like a lovely way to get like an achieved for this question. So what I'm going to do is I'm going to show you guys this couple of things. All right. So we're going to draw up those graphs that. So we're going to draw a graph of like what happens when you draw a curve, and so here is f of x. And then they ask you guys to draw a gradient. Oh, you guys can't see it, can you? Okay, no, sorry. Let me go back here. Let's try this. So here's a curve. They've given you f of x, and then they're gonna ask you to kind of draw f dash of x. So what you want to be doing is this, guys. Take a ruler with you, and I know this is a terrible graph, but like, what you really want to do is kind of like mark that point where there's a turning point. So there's a turning point there and there. We're going to come back here. See, this is what happens. Like, yeah, we'll put a turning point right there. So now, this graph at the top is actually a cubic, and that's all you need to know. All right? You don't need to know the full formula or anything like that. You just need to know that it has two turning points. So when you differentiate it, it's going to have one turning point. Okay? Actually, don't even worry about the x cubed there. We're just going to write this as 2 TPs. All right? And when you differentiate it, you are going to get 1 TP. Abi will actually cover that as well, so don't worry about it. So when it's one turning point, this is two turning points. And again, you could write this as x cubed, which means when you differentiate it, you're going to get 3x squared, which means it's a positive parabola. So as long as your curve goes through this point and it goes through this point, you are pretty much correct. All right, now what I'm going to do is I'm going to keep differentiating this below it so you guys can see what happens. What happens if I differentiate the parabola? Now in this case, the turning point is right there. So parabola, when you differentiate it, it is going to end up looking like a straight line. But as long as it goes through this point here, again, you are correct. Finally, what if they give you a straight line and you have to differentiate it? Now a straight line, when you differentiate a straight line, you have to know what the gradient is. So let's say the gradient in this case is something like 2. Then when you differentiate it, at 2, you will get a flat straight line. So hopefully I've answered that question to you. So always remember that cubic changes into parabola, parabola changes into straight line changes into a flat line. Flat line changes to nothing. It just, when you differentiate a flat line, it becomes 0, and so we just draw a straight line and that's 0. What are we up to anyway? Like, I did say I was going to do a giveaway stream at 30k, but I think we should really be focusing on these exams rather than giveaways. 28.6. Yeah, now I'm not hitting 30k this time. I can leave it again. All right. What if we go backwards? All right. Yes, we're going to do that, Aaron. We're going to do that next. We're actually going to go backwards from... Most of the time I've seen, like, from, what do you call it? Parabola to cubic, they ask you to go backwards. So if you have f dash of x looks something like this. All right, I'm just drawing a rough graph, and I'm going to make it a bit more ugly. Let's actually do something like that. All right, so if you want to go backwards, what you have to do is, once again, we're going to take the ruler, but this time it's really important you do this, right? Because this is a turning point. So what I generally tend to do is kind of like draw up a little line wherever the turning points are happening. My ruler skills are not the best here. All right. So what you have to put is, what do we've got? If we differentiate this, because our turning point is right there, and this happens to be a negative parabola, we're actually gonna, when you integrate it, we're gonna get a negative cubic. Negative cubic looks like this. So here's how you do this. Any one of those things, and sometimes with these questions, guys, they do this as a merit question. They actually say that draw f of x if it has a y-intercept at 3, for example. Like they might say that. So if they say something like y-intercept is at 3, then we have to make sure that the graph actually goes through 3. But at the same time, your turning points could be anywhere. So your curve could actually look like this. Maybe it might look like this. But it still has to turn somewhere there. Now, that's a terrible kind of diagram, but I probably should have done it something like that. That one in the blue, it works. Or you might actually have something like this. Because it's a turning point, it always has to turn. It might look like that. But so as long as you get those curves to go through the turning points and also go through the y-intercept, which is 3, in this case anyway, you should be okay. All right, and once again, I think in 2020, I did a whole session of tutorials on it. Like literally, we spent like one whole tutorial on it. Hopefully that helped you, Aaron. And also remember, guys, last year they did this. So I wouldn't be surprised if they do this year. I think last year they did a thing where they actually had 3 turning points. So if you have a look at the exam papers from last year, I thought I saw this, I could be wrong. Yeah, look at this. So last year they decided to go with an achieved question with an x to the power of 4 graph. Now some of you might have never actually seen this type of question before, because it's like, well, not this type of question, this type of graph, x to the power of 4, but nothing changes, right? If you ever get a graph that you don't recognize, like I wouldn't be surprised if they go with x to the power of 5, but it doesn't matter. All you have to do is just make sure you get a ruler and you kind of mark off your little turning points. So notice how that turning point right there is that red dot. Here's another turning point, so there's a red dot at the bottom, and then here is another red dot. So those 3 points are crucial. Once you get those 3 points, as long as you have any of these rough shapes and the thing can actually go through it, you are pretty much looking at an achieved for it. Which 2021 last question are we talking about? Like this one here, the proof question. Guys, I've already done it, guys. So if you can have a look at the exam video, it would be helpful. Why is the area of triangle D minus Y? Oh, right. Okay, that's a simple one to explain. Okay, so if you look at it, along the curve, right? Did I not? I thought we did that. Did we? No, we didn't. No, we didn't do it. Here, look at this. So this is from the previous question, right? Like, y is the base of the triangle 9 minus y. Now, no, Stacy, the whole thing is, you're right, the whole thing is 9. But if you look at the highlighted part of the blue, right? The blue is the highlighted part, which is the height of the triangle. So if the red is the full 9, the purple part is actually whatever y is. So along the graph, the point that's actually here, that's actually xy. So what you have to compensate is you actually have to remove the rectangle's height to get the triangle's height. You get the full height, which is 9, but then you got to go 9, take away the rectangle's height to get the height of the triangle, and that's what it is. Now, G. Emathor, you can actually use you can use decimals. There's nothing wrong with that. A difficult kinematic, difficult kinematic stuff. I don't know. Like, I think kinematics is like, I think you guys need to remember, differentiate distance to get velocity, differentiate velocity to get acceleration. That's all you need to remember, right? And also the key thing is, like, sometimes they ask you questions like this. How far has something traveled in the 3rd second? So if they ask you something like that, how far, like 3rd second, so you got to kind of go, the 1st second is the distance between 0 and 1. The 2nd second is between 1 and 2. So keep that in mind, right? So keep that it. Sometimes they'll say, how much has this something traveled in the 7th second? So you'd actually go t of 7 minus t of 6. Yeah, minus something to get that thing. Mad Valor, yeah, there are some tutorials available at the bottom of my YouTube page, man. Graphics calculator tips. Okay, ADAC. I'm gonna go back to my notes from 2020, all right? Because, like, trust me, level 2, what did I do? Level 2 calculus. Yeah, I thought I did this somewhere here. Yeah, so trust me, guys, if you're still stuck on kinematics, I would strongly recommend you go check out this tutorial that I did on 19th of August. Like, I did all kinds of questions in it. Like, that whole thing is just about kinematics. Like, yeah, there's about 3 or 4 questions in there that is definitely worth the watch, because it's just, I don't want to sit here doing like same stuff again and again. Big Sir, no, it'll be 2 to the power of x plus 1 minus 3, because if you're trying to move it to the right side, you actually minus 3, not plus. The kinematics tutorial, it is available, where is it? It's available in the playlist of this one, Calculus Live Tutorial playlist, and August 19th. I'll actually link it for you guys, so if you do want to watch it, can I copy link? Yeah, I'll actually put that in there so you guys can watch that kinematics video. Big Sir, that's a level 1 question which we'll cover tomorrow, man, so yeah, stream settings, because I think I put it at low. I put it at ultra low. I should have really moved it to normal, but I keep forgetting it. Perfect square. For discriminant question, when you get 2 answers and k as a range of values, how do we tell which of the ranges? Okay, Shivam, let's quickly kind of cover that, alright, because that actually covers multiple things. So paper, there we go. Okay, so and I think this is probably a good one to finish this finish today's tutorials on, is an algebraic inequation. Like, sometimes, you know, you guys do like the b squared minus 4ac is greater than 0, blah blah blah. You know, you kind of like simplify, yeah, so you kind of like simplify, and then what you end up with is something like, I don't know, x squared. Again, this is just something I'm just making up on the spot, so I hope it works. So something like this. No, you guys can actually see it. Sorry, let me put that screen back on. Yeah, sorry. So let's say you work with a discriminant and you want to find out like for what values it's greater than 0, blah blah blah. Right, you kind of do the substitution, and then you end up with this equation right here, which is a parabola, and it's greater than 0. Now, guys, I need you to listen to this one, all right? Even if you can take this one little thing away, if you get increasing or decreasing functions, you can use this. If you get quadratic equations, you can use it. For discriminant, you can use this. So it's kind of like a very useful skill to have. So with that in mind, what you got to do is you actually solve this. You put x squared minus 4x plus 3 equals to 0. You can factorize it, or you can put it directly in the graphics calculator to get your 2 solutions. We are going to get x is equal to 1 and 3. Now, what you need to do is on the side, you don't get marked down or up or anything like that if you draw the graph. The graph is simply a visual guide to tell you what zones you're actually looking at. And we don't actually worry about the y-axis. We just put the x-axis. Then we put the graph, which is a positive parabola. So it's a positive parabola. And the 2 points that I'm looking at are 1 and 3. And we want to know for what values is this parabola greater than 0. So we can see that it's these 2 sides here. So how do we write this? We actually write x less than 1. I see, and this is a problem, right? I keep going back and forth on this. Is it or is it and? I kind of put comma because then it kind of saves me a bit of hassle there. And so these are my 2 zones where this x squared minus 4x plus 3 is actually greater than 0. But what about if they say x squared minus 4x plus 3 is less than 0? Now for less than 0, we're actually looking at below the x-axis. So in this case, we can actually say it is between 1 and 3. It's a good point, ADAC, but like I would say, look, you could write it down in words if you are like a bit nervous about it. But really, what I do is like, look, who was it that was looking at? I've missed your name. You're asking me whether I could write in words. What I do is like, I kind of do this trick, and I'll show you guys how to do this trick. And it's kind of like a weird trick, but surprisingly it actually works. So let's say we actually have like two numbers here. So I'm going to put down -2 and 4. And here I'm going to put -2 and 4. Now, wherever it's highlighted green, I'm going to actually put down X, right? So in this case, I just write down the -2, write down the 4. So because the X is actually between those two, I put the X like this, and then I put less than sign on both of them, like that, and you're done. Same thing for this. What I do is this one, I put down -2, I put down 4, and because X is on the right hand side of the 4, I put the X here, put the X here, and guess what? I put my two things there. So it's a bit of a weird little shortcut, but it does work if you are like struggling with how to write them in those format. Cormac, it'll probably be like probably merit or excellence. Yes, it does come in level 3 calculus. Oh man, I can't actually read the questions. Jeez. Rounding answers, you can do it up to 2 decimal places. That's always a good one. What if it's equal to 0? Well, if it's equal to 0, you've already solved it, Madalena. So you don't need to worry about any zones. Oh, I've got double exams tomorrow. Can that be written as X greater than 4? Absolutely, ADAC. Yes, you can do that. This is just if you're uncomfortable writing it down like this. So really important that you guys get that zones right? Sketch a parabola from straight line. It just depends on the straight line itself, because if your straight line looks positive, then your parabola is going to look like this. If your straight line is negative, then parabola is going to look upside down. Right, guys, what I'm going to do is I'm pretty much going to call it here, because I just need like a short little break before I do the level 3 paper. Sorry, just got to change a couple of things. So look, all I want to say to you guys is good luck for tomorrow. Don't leave any questions empty, right? You still got a bit of time. You can do a bit of revision tonight, but and then after that, just call it. Yeah, like go get some good sleep. What else can I say? Like, don't leave any questions empty. Like a lot of guys they look at an excellence question and go, oh, this is too hard, I'm not going to do it. My recommendation for you guys is sometimes writing like something in a small bit in an excellence question could get you like an achieved grade. So keep that in mind. So don't leave anything empty, and especially with calculus, like, man, trust me, just differentiating all those questions, you are probably gonna get like a few achieved marks here and there. So, and again, don't stress, guys. Like, look, I'm gonna be honest with you guys. I know it feels a lot at the moment, in terms of like, you know, it's a lot on your plate, but if you ask any of the level 3s that'll be coming in half an hour, they'll be like, yeah, you know, yeah, it's good, it's hard, but you'll get through it. All right. Ryan, the next level 1 stream is going to be tomorrow, just before the exam. Sorry, I've got to kind of been a bit busy with, as you can see, these other 3 levels that's here. What type of question? Wow, like this is, it can't even. Yeah, some of the comments are not even coming in up here, so there's just too many comments that's going there. Level 3 calc, Rohit, I'm doing it in about half an hour. I just need a little tiny break, get some water, and then I should be good to go. I'm from New Zealand, vegan, but I was originally born in India, so. Lily, I'm never doing stats, man. Like, sorry. Like, that's just like too much work. Like, talk about making me work there, right? Like, I struggle to do with like just like algebra and calculus. You want me to do stats? When am I gonna get some sleep? Nah, no stats, no chance and data or anything like that. Just kind of like maybe for some people, it's perfect square minus one. Right. As I said to you guys, good luck. I'll hang around for like a few minutes just to kind of, I'm not answering questions as I switch over my gear. But yeah, look, all the best tomorrow. And yes, I am a school teacher, Caleb. I teach year 9 maths. I was teaching, what was I teaching today? I was teaching area of a rectangle today. That was fun. But yeah, keep going, keep practicing, and I guess if you guys make it through to level 3 calculus, I will see you guys at level 3 calculus. Otherwise, my big thing is, you know, some of you might be done with maths this time around. You might be like unsubscribing, and you know, it's all good. I mean, you got to do what you got to do. But yeah, all the best, and if you see me around the roads, come and say hi, and don't be a stranger. All right. Good luck, guys. Otherwise, I will see you next year for your level 3 streams, okay? No worries. Yeah, I was supposed to get to 100k in 10 years, but I'm at 30k. It's pretty long way to go, but you know what? I'm happy with how things are going here. Appreciate it, SGB. Thank you for that. Yeah, vanakkam Jigar. Eric, there's a person that's called Michael Walden. He does scholarship calc. Have a look at him. He just started his channel on Skull Calc recently. Repeated root is discriminant is equal to 0. Repeated root basically means it's just like one root, that's all. So discriminant is 0. Do you know any good stats and probability channels? Yes, Liz Sneddon is pretty good. Let's go check her out. Actually, this has been a lot quieter. When I consider a few years ago. A few years ago, I think I had like 800 kids on here. That was mental, man. Absolutely. After that, I stopped. I was like, I'm not going to do tutorials before the night of the exam because it's just like too crazy. Steve, that does sound, can you get one real root? Yeah, you could get that. Caleb, I teach at Almaston Junior College. It's in Auckland, man. Wow. Yeah, okay, simultaneous. I don't know. Favorite topic? What do you, I don't know. Just don't know when you say favorite topic. JJ Dutch, you know me, man. Like, I hardly get any spare time. It's like, I wish I had spare time. In fact, I think I'm looking forward to the holidays because I don't have to, like, I'm looking forward to next week, Wednesday, because I don't have to do nighttime tutorials for a while. Oh, thank you, Mark. Appreciate it, man. You don't have to. You guys don't have to do anything like this. Don't worry about it. Just look after yourselves. Now you can write one real root, Steve. So yeah, 10 lad. We're starting in about 25 minutes, but I might start a bit early tonight. But JJ Dutch, don't worry, man. Like, that's, you don't have to worry about that at all. Like, seriously, do not worry about like any kind of donations here. Just do what you can. ADAC, I had about 3 people come, which was actually more than enough. I struggled with the three because it was like 2 level 2s and a level 1, and I kind of was just like helping out both of them, and I was trying to help out. Yeah, Zaki, I'm in Auckland, man. Nah, JJ, like I used to, but like I think I don't know. This last kind of 1 year has been this year has been like absolutely mental because I started going lives a lot more. I started my own business on the side, and then yeah, it's just been like really busy. Like I haven't actually run in a long time. I was talking to my mates about this. I was like, man, I miss running. Um, like I stopped going to the gym. Just been like, just I don't know. It's not healthy. I know that much. It's not healthy to not look after myself. Um, so I don't know. Maybe I think I'll have to reassess a few things after this set of set of tutorials, and then kind of figure out how do I want to do. Yeah, yeah, I know. There's heaps of stuff here, um, but it's always like it's a weird one, right? Because it's like when kids want to come to a tutorial, they're making a choice to learn something, and at that moment, I don't know. I just feel like it's my responsibility to kind of stay here and help out as a teacher. So yeah, that's where it kind of comes from. Yeah. Right. So I'm gonna take a 20-minute break, and then yeah. DPC, I am gonna do that next year because I was talking to my wife about this. She was like, every time you go visit a place, you should actually come around and like let them know that you're coming to a library and just sit out. Oh, Toby, mate, you didn't. Jeez, guys, like seriously, thank you, Toby. I appreciate it, but seriously, you don't need to, man. You don't need to do that at all, but I appreciate it. Um, yeah, so I'm coming down to Wellington, I think in early January. So I don't know, maybe I'll do like a, I don't even know, what do you do? What do people do like in like it's odd, right? Like it's not like you go and see your teacher on the holiday. Like, if your teacher says, are they gonna go to the like I don't know, they're gonna be at a place, you're gonna be like, nah, hell, I ain't going down there to go to um gonna go see your teacher. So I don't know, I just feel weird. But like maybe I'll bring like a couple of t-shirts and say, look, first 3 people to solve this question and find me in Wellington gets like these t-shirts. That would be a fun thing to do, like a scavenger hunt, right? And let's just, in the end, no one comes, and then they're like, come on a tutorial and like, hey, can you help us solve this question so we can come and find you? That would be a crack up to do something like that. Do a show where you complete papers. Annie, I've got a whole series in my store, so you can always go and order. No, Fidel, I don't mark externals. Nah, Flamingo, it's not about money, man. It's just about helping people, right? Favorite show? No, wait, we shouldn't be talking. We like wasted 8 minutes of your life. I wasted 8 minutes of your life. You guys should actually get back to work. I'm gonna stop the stream, and I'll tell you what. When the exams are over, we'll have like a bit of a chat session where you guys can just kind of come in and have a chat, and we'll just chill out a bit more rather than trying to do this before the night of the exam. That's just selfish of me. Shamang, Anshul, thank you for the donation, but Anshul, I don't know. Does he go to Ormiston Senior College? Because I'm in Ormiston Junior College. Yeah, now we'll do a chat when things are gone through. Oh, where do you buy a shirt? You can just message me on Instagram or just email me and let me know, and I'll send you an invoice, and then I'll send you a T-shirt as well. Hooligan, start with the live tutorials playlist. You'll be fine. I do, but it's not. I don't really spend too much time on it because it's like it's being managed by somebody else. But yeah, but look, time, guys. I gotta go. I need to get the 20-minute break because those excellence questions at level 3 are like a head scratcher. But look, good luck. I'll see you guys around the bend like next year at level 3. Answer every question. Have a good one, and don't come and bug the level 3s when we're doing the level 3 tutorial. All right. Catch you guys later. I'm gonna end the stream, man. Oh, now is a good time to, what? Oh, okay, sorry, I did something stupid there. I didn't realize what that was. What just happened? I don't know what happened. I clicked on some button and yeah, I hope it didn't go through, but anyway. End stream. See you guys. See you later.